These notes are for AP Calculus and the introduction of chain rule. We have done derivatives. We've done the definition of derivative using limit. We've done basic differentiation. We've done power rule, product rule, quotient rule. Chain rule needs to be used in specific cases, and you might have to do it at the same time you're using those other rules. So you just have to be very careful. I'll go through these examples, but practicing it is going to be the best thing that you can do. There's a couple different ways to teach this, and you're going to have to decide which one works better for you. So this chain rule is going to say dy dx, the derivative of y with respect to x, is going to be equal to the derivative of y with respect to u multiplied by the derivative of u with respect to x. And that's looking at this as this function. It's a combination of a function in a function. And I look at it this way because this is going to help later on when we're doing integration. The other way to look at this is you're taking the derivative, and there are two functions involved. One function is placed within the other function. And when you do that, you have to take the derivative of the outside with a composed function multiplied by the derivative of what's inside. So let me show you a couple examples. With this first example, I have y equals 1 over x plus 1. We can't take the power rule. This can't be 1 over x plus 1 to the negative 1 with what we did before. But you got the right idea. Before we could do 1 over x or 1 over x squared. But this x plus 1 changes. That's the other function we're talking about. So I'm going to say du is equal to x plus 1. Then I'm going to say the derivative of u with respect to x is just going to equal 1 using the power rule. So then if I rewrite this, this u is equal to 1 over, or I'm sorry, y is equal to 1 over u, or u to the negative 1. So dy dx is equal to negative 1 u to the negative 2 times du dx. This is when I can go back and replace u. Once I've taken the derivative, I can go back and replace u with what I have up here. So dy dx is equal to negative x plus 1 to the negative 2 times 1. So dy dx is equal to negative 1 over x plus 1 squared. If you did this with the product or with the quotient rule, this is just a quotient. And I can do it fairly quickly to show you, but this isn't always going to work. So if I had dy dx, low times derivative high minus high times the derivative of low, all over low squared. This is 0, this is negative 1. Now I show it to you with this one, but it doesn't work every single time. So one of the things you're going to have to do when we are done with this section is when you have to take the derivative, you're going to have to figure out what method you want to use and which method work best. So let's look at this next example. My function is the square root of something, but the something inside is no longer just x. If I want to take the square root of x, I would say, well, that's x to the 1/2. This is a function within there. So I'm going to let u equal 3x squared minus x plus 1. So du dx is going to equal 6x minus 1. So let's go ahead and write this. I have y is equal to u to the 1/2. So dy dx is equal to 1/2 u to the negative 1/2 times du dx. Now I can replace everything. So dy dx is equal to 1/2 3x squared minus x plus 1 to the negative 1/2 times 6x minus 1. Nothing wrong with that. That's fine the way it is. If you want to clean up a little bit, I'm going to go ahead and just rewrite everything. So 6x minus 1 is my numerator. My denominator is 2, 3x squared minus x plus 1. I have, some people think of it without doing this u substitution. So if you want to do that, just ignore this for a second right now. If I want to take the derivative of this, whether it's y prime or dy dx, well, I know I have a square root, so I know I have to have 1/2. This has got to be taken to the negative 1/2 power, because I'm going to take 1/2 minus 1. But then I have to multiply by the derivative of what's inside here. So I get the same thing without saying what u and du is equal to. And some people are fine going right from here to here. Other people are not. So choose what works best for you. My next one, I have got y equals 3x minus 2x squared to the third power. Let me go ahead and show you what this looks like without doing u substitution. So I want to take the derivative. So this is going to use the power rule. The 3 is going to come in front. I'm going to take this 3x minus 2x squared, subtract 1 from the 3. This is a power rule. But the difference is now this function here is just, it's a more involved function inside a function. So then I have to multiply by the derivative of what's here. So I have 3 minus 4x. There's a lot of ways in a multiple choice test that you can see this rewritten, and I'll show it to you in a while. If I want to take u substitution, I would say u is equal to 3x minus 2x squared. Du dx is equal to 3 minus 4x. So dy dx is equal to, let's do it this way. Y as a function of u would be equal to u cubed. Y prime equals 3 u squared times u prime. So then I could substitute back in. Y prime is equal to 3 u squared is 3x minus 2x squared squared times u prime, which was up here, 3 minus 4x. So you see you get the same answer. If you're doing a free response question, keep your answer at this form right here. Don't take a chance of getting something wrong. On a multiple choice, more than likely what's going to happen is they're going to look at this and say, okay, I have dy dx. I have this 3. But look at this, I have an x and an x squared. So I can factor out an x here, but I can factor it out twice because there's 2 of them. So I have a 3x squared. This stays 3 minus 2x squared, and this is 3 minus 4x. More than likely on a multiple choice test, this is what you're going to see, but this is the answer. I'm going to put a box around. I don't want you to take too many steps and then get something wrong. Okay, well, this also works with trig. I've got y equals cosine 3x squared. So you can easily see this 3x squared is a function within the function of cosine. So that means I'm going to have to take the derivative of cosine multiplied by the derivative of 3x squared. So I'm going to say u equals 3x squared. Du dx equals 6x. So y is equal to cosine of u. Y prime is equal to negative sine u times u prime. And notice I'm going back and forth between du dx and u prime. It doesn't make a difference. I want to make sure you're comfortable with all forms. So then I can substitute back in, and I've got y prime is equal to negative sine, u is 3x squared, times 6x. Nothing wrong with that. Most of the time it's going to be written with the sign last, so it'd be written negative sine, or negative 6x, sine 3x squared. The next video I'll make will be all trig with chain rule.